Sometimes the best engineering get killed for the worst reason. Lawyers, regulators, and insurance companies have banned some of the most brilliant tractor innovations ever created. Today, we're counting down 12 banned tractor features that were actually genius and why they'll never come back. Number 12. Hand crank starting system. They called it primitive when electric starters took over. Dangerous, they said, too risky for modern farming. But hand crank starters were actually one of the most reliable engine starting systems ever designed. Here's what the safety experts missed. Electric starters fail, batteries die in cold weather, solenoids corrode, starter motors burn out. But a hand crank? That worked every single time, in any weather for decades. The International Harvester Farm All-M used a hand crank system from 1939 to 1952. Four-cylinder engine with 248 cubic inches of displacement. That crank could spin over 35 horsepower of engine in weather that killed electric systems. No battery to freeze, no wiring to corrode, no starter motor to burn out. Farmers in remote areas loved them because they never left you stranded. Your grandfather could start a hand crank tractor at minus 20 degrees, while modern machines won't even turn over. The danger was overblown. Yes, kickback could hurt you, but experienced operators knew the technique. Proper hand position, smooth motion, and engine timing eliminated most risks. What they built was a foolproof system that worked when everything else failed. Modern tractors need jump packs, battery warmers, and dealer service calls when starting systems fail. The hand crank needed a strong arm and 15 seconds. But one lawsuit too many. Ingenious engineering got replaced by convenience that breaks. And it wouldn't be the last time regulators killed a feature that worked better than its replacement. Number 11. Steel lug wheels. Everyone celebrates the switch to rubber tires. Better ride, they said, improved traction on roads, but steel lugs were actually superior for serious farming, and that's exactly why they got banned. Steel lugs bit into soil like nothing before or since. Cast iron spikes that could grab in conditions where rubber just spun helplessly. No air pressure to maintain. No punctures from thorns or debris. No sidewall failures that left you stranded in the field. The John Deere Model A ran steel lugs from 1934 to 1952. Those lugs could pull through gumbo mud that stopped rubber-tired tractors dead. They lasted decades without replacement. No tire shops, no repairs, no monthly pressure checks. Here's the engineering brilliance. Steel lugs transferred maximum engine torque directly to the ground. Every bit of power went to forward motion instead of being absorbed by flexing rubber. In soft conditions, they were unbeatable. The problem wasn't performance, it was politics. Road departments complained about pavement damage. Neighbors didn't like the noise. Insurance companies saw liability in everything. But farmers knew the truth. Steel lugs outpulled rubber in real field conditions. They just couldn't say it publicly after the lawsuits started flying. Modern tractors spin expensive tires in conditions where steel lugs would have marched right through. But convenience beat capability, and lawyers beat logic. And once they got rid of lugs, the regulators set their sights on something even more iconic. Number 10. Tricycle front ends. They called them unstable death traps. The narrow front end became the poster child for unsafe tractor design. But tricycle configurations were actually brilliant solutions to real farming problems. Problems that modern wide-front tractors still can't solve as well. The close-coupled front wheels weren't an oversight. They were precision engineering for row crop farming. That narrow stance allowed impossible maneuverability between corn rows, through orchards, and around obstacles that wide fronts couldn't handle. The Farmall Super M with tricycle front could turn in a 12-foot circle, 41 horsepower that could pivot like a sports car. Try that with a modern wide-front tractor. You'll need twice the space and 3 times the effort. Here's what the safety crowd never understood. The instability was controllable with proper technique. Experienced operators knew how to read terrain, manage speed, and use weight transfer. The learning curve was steep, but the payoff was unmatched precision. Farmers could cultivate right up to plant stems without damage, navigate between rows that modern tractors can't even enter, work in orchards and vineyards where wide fronts simply don't fit. The real genius was the physics. That narrow front concentrated weight exactly where you needed traction for pulling, better weight distribution for implement control, superior steering response for precision work. But lawsuits from inexperienced operators killed the design. Insurance companies refused coverage. Regulatory agencies mandated wide fronts for safety. Today's farmers struggle with wide front tractors that can't match the maneuverability farmers had 70 years ago. Progress, they call it. But the same progress would soon come for the back of the tractor too. Number 9. Unshielded power takeoff systems. The exposed PTO shaft became farming's most feared component. Regulators demanded guards, shields, and safety systems that added complexity and failure points. But the original unshielded design was actually engineering perfection for experienced operators. direct mechanical connection from engine to implement. No guards to catch debris, no shields to interfere with attachment, no safety systems to malfunction when you needed power most, just pure, reliable torque transfer that never failed. The International Harvester 300 utility delivered 35 horsepower through an unshielded 540 RPM PTO. That system could run hay balers, mowers, and on augers for decades without maintenance. No guards to remove for service, no shields to replace after damage. Here's the brilliance. Experienced farmers developed situational awareness around live PTO systems. They knew exactly where the danger was and how to avoid it. Like working around any powerful machinery, skill and experience eliminated the risk. The unshielded design also prevented the problems that plague modern tractors. No guards to clog with crop residue, no shields to interfere with implement hydraulics, no safety systems that shut down power when you needed it most. Professional operators preferred the clean, simple design. They could see exactly what was happening. Service implements without removing protective devices, diagnose problems at a glance. But one too many accidents from inexperienced operators, and the lawyers got involved. Complex safety systems replaced simple awareness. Failure-prone guards replaced operator skill. Modern PTO systems break down, clog up, and shut off when you need them most. The dangerous original design just worked. But after regulators buried the PTO in shields and guards, they went after something else that worked perfectly fine. Number 8. High-speed road gears. Transportation capability that let tractors move at highway speeds seemed like progress until safety regulators killed it. But high-speed gearing was actually brilliant engineering that solved real logistical problems farmers still face today. Early tractors crawled between fields at walking pace. Moving equipment meant loading on trailers, hiring trucks, or accepting hours of travel time. High-speed gears changed everything overnight. The Minneapolis Moline GTB could hit 40 miles per hour on public roads. That wasn't recklessness, that was efficiency. Farmers could move between distant fields in minutes instead of hours, cover territory that would have required multiple machines or costly transportation. Here's the engineering genius. Those high-speed transmissions used the same heavy-duty components as field gears. No separate overdrive units to fail. No complex electronic controls. Just mechanical reliability scaled for highway speeds. The speed capability wasn't forced on operators. It was available when conditions permitted. Experienced farmers knew when to use it and when to stay slow. Like every powerful tool, it required judgment and skill. But insurance companies saw liability in everything. Regulatory agencies imposed speed limits. Equipment manufacturers retreated to conservative designs to avoid lawsuits. Today's farmers spend hours crawling between fields on equipment that could technically move faster. Modern tractors are artificially limited to protect manufacturers from legal exposure. The brilliance was trusting farmers to use tools responsibly. The tragedy was assuming they couldn't. But what happens when the thing designed for safety is banned instead? Number 7. Open operator platforms. They called them death traps when rollover protection became mandatory. No cab, no seatbelt, no survival cell. But open platforms were actually superior designs for most farming operations, and many farmers knew it. Open platforms gave operators complete situational awareness, full peripheral vision, immediate exit capability in emergency situations, direct communication with ground crews, natural ventilation that prevented heat exhaustion during long days. The Ford 8N's open platform put operators in complete control of their environment. They could see implement operation, monitor crop conditions, and respond to changing situations instantly. No cab windows to obstruct vision, no enclosed space to trap heat and fumes. Here's what safety engineers missed. Most tractor work happened at low speeds on relatively flat ground. The dramatic rollover scenarios used to justify enclosed cabs were statistically rare compared to everyday operation where visibility and awareness mattered more. Experienced operators developed natural balance and positioning skills. They knew how to shift weight, brace for rough terrain, and exit safely when necessary. The learning curve was manageable for serious farmers. Open platforms also eliminated the claustrophobia and isolation that many operators experienced in enclosed cabs. Direct connection to the work environment, ability to hear engine changes, implement problems, and approaching machinery. But lawyers painted catastrophic scenarios, and regulators mandated enclosed protection. Complex, expensive safety systems replaced operator awareness and skill. Many farmers still prefer open platforms for specific operations, but legal liability has made them extinct on new equipment. And with open stations gone, regulators weren't finished. Number 6. Unclutched PTO systems. The Always Live PTO became farming's most regulated feature, but constant power delivery was actually brilliant engineering for continuous operations, and farmers who knew how to use it safely preferred it over modern alternatives. Direct mechanical connection meant implements never lost power during operation, no clutch to slip under load, no engagement lag when restarting, no complex hydraulic or electric controls to fail, just constant, reliable power delivery from engine to implement. The John Deere Model B delivered steady PTO power through a simple gear drive, 17 horsepower that stayed constant regardless of engine load. Hay balers, threshing machines, and belt-driven equipment got smooth, uninterrupted power that made them more efficient and productive. Here's the engineering brilliance. Constant PTO power eliminated the start-stop cycles that damaged implements and reduced productivity. Threshing equipment maintained optimal speed. Hay balers never missed a tie. Belt-driven machinery ran smoothly without power fluctuations. Professional operators developed safe work practices around live PTO systems. They understood the hazards and eliminated them through proper procedure. Like any powerful tool, it required respect and skill, but it delivered superior performance. The constant power also prevented the mechanical shock loads that occur when implements restart under load. Longer implement life, fewer breakdowns, better crop processing quality. But safety regulators couldn't accept that some operators might prefer performance over convenience. Complex clutch systems replaced simple reliability, and farms became less efficient in the name of safety. Modern PTO systems fail, slip, and shut down when implements need power most. The dangerous original design just kept working. Don't forget to hit that subscribe button, because the next 5 features will show you just how far engineering has fallen. But as soon as constant power was outlawed, regulators found a new target. Number 5. Rear-mounted cutting equipment. Direct mount mowers and cutting implements became the ultimate regulatory target. Exposed blades, they said. No protection from debris. But rear-mounted cutters were actually the most efficient grass and crop cutting systems ever designed. Direct blade exposure meant maximum cutting efficiency. No deck to restrict airflow, no housing to trap debris, no guards to dull from impact, just sharp blades doing exactly what they were designed to do, cut cleanly and efficiently. The Bush Hog rotary cutter could handle everything from grass to small trees. Heavy-duty blades spinning at 2,000 RPM with nothing to interfere with cutting action. One pass-through brush that would clog and stall modern enclosed systems. Here's the engineering genius. Exposed blades could handle variable conditions without modification. Tall grass, thick brush, uneven terrain. The cutting action adjusted naturally to whatever it encountered. No preset deck heights or restricted operating conditions. Professional operators knew how to work safely around exposed cutting equipment. They understood debris patterns, maintained safe distances, and used proper technique. The learning curve was manageable for serious farmers. The direct mounting also provided superior weight distribution and implement control, better tractor stability, more precise cutting height control, easier maintenance access for blade changes and adjustments. But liability lawyers painted horror scenarios of flying debris and accidental contact. Complex enclosed systems replaced simple effectiveness, and cutting efficiency dropped dramatically. Modern mowers clog, stall, and struggle in conditions where exposed blade systems cut cleanly. The dangerous original design was just more effective. And once regulators blunted those blades, they moved to the front of the tractor. Number 4. Manual steering systems. Power steering became standard equipment when regulators decided manual steering was too demanding for operators. But mechanical steering systems were actually superior for precision work, and many farmers knew it. Direct mechanical connection between steering wheel and front wheels gave operators precise feedback about traction, implement load, and ground conditions. No hydraulic lag, no power assistance to mask problems, just immediate, accurate response to steering input. The Case Model D used a worm and sector steering system that lasted decades without service. Manual steering that provided exact control over implement positioning. Operators could feel exactly what the tractor was doing through the steering wheel. Here's the engineering brilliance. Manual steering forced operators to read terrain and plan ahead. They developed superior driving skills because the machine demanded attention and technique. Better operators meant better fieldwork. The mechanical systems also eliminated the hydraulic complexity that plagues modern tractors. No pumps to fail, no fluid to leak, no valves to malfunction, just gears and linkages that worked reliably for decades. Precision work actually benefited from manual steering. Cultivating, planting, and harvesting required exact implement placement. The direct mechanical feedback helped operators maintain accuracy that power steering systems couldn't match. But comfort became the priority over capability. Complex hydraulic systems replaced simple mechanical reliability, and precision farming got less precise. Many custom operators still prefer manual steering for detail work, but modern tractors don't offer the option. And after manual steering was pushed aside, the regulators took on something even more critical. Number 3. Mechanical fuel injection. Simple mechanical fuel systems became environmental targets when emissions regulations demanded electronic control. But mechanical injection was actually superior engineering for agricultural applications, and still is. Mechanical injection systems used engine RPM and load to control fuel delivery. No computers to fail, no sensors to corrode, no software to corrupt. Just mechanical precision that matched fuel delivery exactly to engine demand. The International Harvester DT466 engine used mechanical injection that lasted 200,000 hours without major service. Precise fuel metering that delivered optimal power and efficiency across all operating conditions. No electronic failures to strand farmers during critical seasons. Here's the engineering brilliance. Mechanical systems adapted automatically to fuel quality variations. They compensated for altitude changes. They adjusted for engine wear, all without electronic intervention or dealer recalibration. The mechanical design also eliminated the complexity that makes modern engines unreliable. No electronic control modules to replace, no sensors to clean or calibrate, no software updates required, just mechanical precision that worked year after year. Field conditions that kill electronic systems had no effect on mechanical injection. Dust, moisture, temperature extremes, and electromagnetic interference couldn't disrupt purely mechanical operation. But emissions regulations forced electronic control systems onto agricultural engines. Complex technology replaced simple reliability, and farmers started carrying diagnostic computers instead of wrenches. Modern tractors break down from electronic failures that would never affect mechanical systems. The primitive original design was just more dependable, but after regulators killed mechanical injection, they went after an even simpler system. Number 2. Gravity feed fuel systems. Simple gravity-fed fuel delivery became a regulatory target when safety agencies demanded complex tank and pump systems. But gravity feed was actually the most reliable fuel system ever designed for agricultural equipment. Elevated fuel tanks used gravity to deliver consistent fuel pressure without pumps, filters, or electronic controls. Tank placement above the engine created natural pressure that matched consumption across all operating conditions. No fuel pumps to fail, no pressure regulators to stick, no electrical systems to corrode. The Ford 9N used a simple gravity system that delivered fuel reliably for decades. Tank mounted above the engine with a single fuel line and gravity-operated valve. That system could run for thousands of hours without service or failure. Here's the engineering genius. Gravity never failed. Unlike electric pumps, mechanical pumps, or pressure systems, gravity provided constant, reliable fuel delivery regardless of conditions. No power required, no maintenance needed, no components to wear out. The simple design also eliminated fuel contamination problems. Single tank-to-engine path with minimal connections. No pumps to introduce air. No complex routing to trap water or debris. Clean fuel delivery that prevented engine problems. Field conditions that destroyed complex fuel systems had no effect on gravity feed. No electrical connections to corrode. No pumps to clog. No sensors to fail. Just reliable fuel delivery that worked in any environment. But safety regulators demanded contained fuel systems with vapor recovery and leak detection. Complex technology replaced simple physics, and fuel system reliability dropped dramatically. Modern tractors experience fuel delivery problems that would never affect gravity-fed systems. The primitive original design was just more reliable. But what happens when even gravity itself isn't safe enough for regulators? Number 1. Compression release. Starting, the compression release system became the ultimate target for safety regulation. Manual decompression for easier starting seemed dangerous to agencies that demanded electric starting systems. But compression release was actually the most reliable cold-weather starting system ever created. Manual compression release allowed operators to reduce engine compression for easier cranking, then restore full compression for normal operation. Simple lever-operated valves that solved starting problems no electric system could match. The John Deere Model A used compression release that let operators start the engine in conditions that killed electric systems. Two-cylinder engine with manual decompression that worked at -30 degrees when batteries and starters failed completely. Here's the engineering brilliance. Compression release eliminated the massive electrical power needed for cold starting. No batteries to freeze, no starter motors to overheat, no electrical systems to fail, just mechanical advantage that made starting possible under any conditions. The manual system also gave operators complete control over the starting process. They could adjust compression based on conditions, fuel quality, and engine temperature. Precise control that automatic systems couldn't match. Professional farmers preferred compression release because it never left them stranded. Electric systems failed in cold weather, remote locations, and during critical seasons. Manual systems worked when everything else quit. But regulators decided manual starting was too demanding for modern operators. Complex electric systems replaced simple mechanical reliability, and farmers started depending on systems that failed exactly when they needed them most. The dangerous compression release just worked, every time, in any weather, for decades. Engineering brilliance killed by regulatory fear. These weren't design flaws. They were solutions that worked better than anything we have today. But lawyers beat logic, and convenience replaced capability. Which banned feature do you miss most? Let us know in the comments below, and subscribe for more truth about farming's forgotten innovations.